Okay, we're going to get started. Thank you for joining us today. We here at Chef are really happy to have Darren McCool at Scholastic, Chris Munns from the AWS team, and Julian Dunn on our team join us for a conversation about how Scholastic chose to move to the AWS cloud, how they use Chef. Darren's going to walk us through that journey, some of his successes and some of his challenges, and so Darren will sort of walk us through all of that story in about 25 to 30 minutes. There's an active question button here in the tool, so we encourage everyone to ask questions, submit questions. What we'll do is, as a group, we'll take all those questions at the end and answer as many of those as we can. So, again, thank you for joining us. I'll hand things over to Darren. Darren.
Hello, everybody, and thank you for joining us. As Justin mentioned, we're just going to briefly walk you through Scholastic's journey to the cloud and how we leverage both Amazon and Chef to get us there. So, it's a quick agenda. I'm going to give you a quick description of who Scholastic is and where we are and what our problem was and why we chose to move to the cloud, why we chose to move to AWS, why we're using Chef, and then I'm going to go through a little bit more of a technical detail of how we're using Chef and how we're leveraging Chef and the benefits that's giving us. So the first thing is, who is Scholastic? So we are the largest publisher of children's books in the world, and we're also a leader in educational technology services in children's media. So we're serving customers in over 45 languages, and we're in over 150 different countries. And we have right around 10,000 employees work for Scholastic around the world. So some of our longer-running big titles have been Clifford the Big Red Dog, The Magic School Bus, Goosebumps, Harry Potter, and The Hunger Games. Anyone on the call happens to have kids or might remember from them being in grade school, you might remember your teacher handing out the Scholastic flyer. You check off the books you want, and then a few weeks later we ship books to the school that you're able to bring home and read. So that's still a big part of our business, and that's what we do every day. So our main focus is teaching literacy to children around the world. So what is our problem? So we discussed possibly moving the cloud maybe about 24 months ago, and the real reasons we're doing this is we were looking at some of our network infrastructure, some of our server infrastructure was approaching end of life. There's a large capital investment for us to renew the hardware, and even with the hardware we had in the data center, we had a lack of agility and a lack of elasticity. Basically, meaning our ability to grow and our ability to bring things to time to market wasn't what we wanted to be. But if you take a step back, the real issue there is Scholastic, like I said, is a children's publishing company. We're not in the data center management business. But for a long period of time, we kind of had to be in the data center management business to facilitate giving our customers the services they wanted. So, we looked around to see what the other options are and see how, is this a problem other companies are having? And we found out that, we're not alone. So once we understood that we weren't alone, we started talking to various vendors, including Amazon, and looking what our options were, and and to see if the cloud was a good fit for us. So the slide I have up now is one of the slides we got from our partners at Amazon that help us outline what our current costs are and basically build a business case of what should we do. And this outlines, the four, and this slide kind of outlines the four highest costs you have that, help you determine where your costs are. There's the server costs, and then, that's the server, the rack, the space, the cooling, the labor, power, there's the OS, the storage, and the network costs. And the network costs happen to be the actual highest factor for us, just because replacing core switches or core routers is not exactly an easy task. So, it was help us decide the factor. It was a deciding factor for us deciding where we wanted to move. So we had to set a direction. When we were having this discussion internally, we could have just refreshed the data center and kept everything as is. We could have refreshed the data center and used a lot of the different private cloud tools that are being advertised in the market space now. We could have moved to public cloud, or we could have done some sort of hybrid. So earlier I said is, at Scholastic at least, we don't want to be in the data center management business. So refreshing the data center and doing private cloud and doing hybrid all kind of require us to maintain, the same data center footprint or a similar data center footprint that we have now, which really wasn't what our goal was. So we went down the path and we decided that, us moving to the public cloud allowed us to meet our business objectives better than any other option. And then once we knew we were doing that, we did some more research and spoke to some other companies around, and we decided the best vendor to use as our cloud partner was Amazon Web Services. So, after doing the research and, doing getting the Gartner reports on Amazon and things like that, we knew the cloud was ready for us. We knew the cloud was mature when we decided to start setting the direction of moving towards the cloud. The other question the question there came from us though, which is, are we ready for the cloud? And that was really more of the question for us than is the cloud ready for? Are we ready for the cloud was a bigger question for us than the other way. And you have to realize that things are a little bit different in the cloud. So we had to see, what's going to be different and what's not. So one of the things that we did that I would recommend that, and some things we learned is, when you're moving to the cloud, if you're used to a data center model and you haven't done any virtualization, working with Amazon directly and or an Amazon partner is highly recommended. It's don't try to learn this on your own. Leverage the tools and the resources that are out there to help you get there, to help lay down your topology, your process, and get your internal stuff up to speed with cloud concepts. The other thing there too is also reach out to all of your different stack vendors. If you're using IBM, Red Hat, or whoever you're using, and let them know that you've decided to move to the cloud, because a lot of those software products or stacks have a different licensing model or different versions of the software that is cloud ready. So so leverage all the relationships you have and try to establish a relationship with someone who's familiar with the cloud at the beginning to help you on your journey to the cloud. So then when you start going to the cloud and you start diving into it, you're going to see some things are different. So one of the things we came to the conclusion early is automation and configuration policy management becomes paramount. And that's why we started leveraging Chef. So, there's an old saying, in a data center, servers develop personalities, because, you build a server, and that server is going to exist, for a period of time, 3 to 5 years, if you don't refresh very often, maybe even up to 6 years. In the cloud, servers don't typically last that long, because you can refresh your servers so much easier in the cloud. There's not a capital investment that you had to invest to get the server put in place, that when you're done with the server, you just destroy it. You blow it away. So servers, the way you look at servers is different. When you realize that you'll be building and destroying servers on a regular basis, that's where automation and configuration policy management really comes important. With that, a few things change. So, DevOps becomes DevOps. And what am I trying to say there? Because I have the capital Dev in the second part. So a lot of the administration teams in your data centers are probably used to logging onto the servers and making manual changes to servers everywhere, whenever they want, how they want, within change control. But the difference there is when you start leveraging automation tools like Chef and to start rapidly building servers, the DevOps team, the administration team, have to acting more like developers than administrators. Opposed to making a change on a server, you're actually going to make a change to your cookbook, and then you have to version that cookbook. and then you have to promote that cookbook through your different environments. So one of the things culturally we actually had to address was getting our administration staff to start thinking more like a development staff. We actually had to teach them code versioning concepts, and we're leveraging a Git repository for our cookbooks. And that took a little while for some of the folks there to get used to that, because all of a sudden, they'd make a change on the server and it would work, and a half hour later when the chef client ran again, it wouldn't work. It's like, yes, because you actually made a change on the server, not to the cookbook, and the configuration policy tool is doing its job and keeping it at server in compliance with the template. So there's a little bit of time that we had to spend culturally getting our teams ready and getting their minds around how to approach the new world as far as, we're looking at. We look at infrastructure as code now. Everything is by code. The days of having somebody manually sit there for hours and hours and hours and just build a server manually, from our point of view, is gone. And there are some advantages of that. So problem resolution is different. Like we had an instance, I don't know, like 5-6 weeks ago, where in a development environment, a developer had made a change to a server, and we had one of the admins who's like, all right, I have to spend a good part of the day today debugging this. I was like, you don't actually. Just destroy the server and rebuild it from the cookbook. So I suppose that person having to spend a half hour or 45 minutes or longer trying to debug a problem, since we know we had a known good template from our cookbook, we just destroyed the EC2 instance, rebootstrapped it, rebuilt it, and within a half hour, we were back to normal, and we were able to continue on down our path. So that's a very different way of looking at it. You don't always have to debug every issue. If someone made a change and you're not sure what they did, don't debug it. Just throw it away and rebuild it. The other thing you start to see empowered developers. So, and your system administration team is going to have to get used to servers being created and destroyed by other people in operations. So one of the things we did is we had this system, and I'll have a diagram later on in the deck that outlines it, that we self-empowered developers. So developers can actually create their entire application stacks in development without having to go through the system administration team. They could build them, and then when they're done, destroy them as they see fit. So by doing that, for the software development lifecycle, what we really did is we really took the infrastructure slash system administration team's process away from being a bottleneck. We can move as fast as the developers can move, and the developers can leverage our systems without even having to reach out to us. We still have some governance from QA and above, and that's because we have to comply with SOX and other things that have nothing to necessarily do with the technology. When you're destroying and building servers, or building and destroying servers on a regular basis, server names become useless. So that's a little bit of a cultural change that you have to get used to, which is everyone's used to. Sometimes the development environments historically didn't even have a real DNS name. It was everyone was testing directly against the server name, and everyone just sort of memorized that server name as development. But those days are kind of gone. So one of the things we did is actually we built true DNS names for all of our environments, because we knew the servers behind those environments would be different on any given day depending on how many iterations of changes we were implementing. So that was a little bit of a culture adjustment we had to make, but technically that was very easy to implement. So some other cloud tag concepts we're using is tagging and right sizing. So one of the things we did early is we built a taxonomy for tagging. So whenever we light up an EC2 instance, we outline the business unit it belongs to, the development it belongs, the environment it belongs to. We define some services. So in other words, is it an Apache server? Is it an application server? Is it a database server? And then, I guess from our point of view, or at least from a costing point of view, is the cost center that the team that spun that server up belongs to. Because one of the things that we learned early on, and then we had to make an adjustment, is when you self-empower the development teams to spin up servers as they see fit, as often and as easily as it really is, is it's kind of important to provide them with some incentive to turn the service back off. Otherwise, you find the same thing if you ever have kids, or if your kids walking around the house and the lights are always on. If people don't ever turn the servers off, you're actually running costs in the cloud actually might be even higher than your data center. So you have to, build some sort of governance to make sure people turn servers off when they're done with them. And we found having their boss get the bill every month worked out pretty well for us. So at the end of each month, every single business unit or cost center owner gets, we run a report off the tags we have, and they get a result of here's what your run rate was from, for this month or this quarter. The other thing that is different in the cloud that we really liked is right sizing. So in the data center days, if you bought a server that was 2 CPU for an application that you thought was going to be small, but it got really popular, you had to order new servers. And that could take weeks and weeks to come in. Or if you think something's going to be a really big hit, you order these really big servers, now all of a sudden it wasn't as big as you thought it was going to be. You now have this really, really, really big server serving a very small audience. So in the Amazon cloud, you're able to adjust the size of your servers as needed. And Amazon actually has something called Trusted Advisor, which gives you great guidance of, how well optimized your servers are and things like that, and where there's opportunities to either grow or cut costs. So that's those are some significant differences between how you look at these things from a data center point of view to a cloud point of view. So again, some other considerations is as you're building servers, at will, you really want to make sure that you have you want to guarantee that the server, and then sometimes, especially if you're using SOA and you're building multiple stacks, you want to make sure there's entire environment parity. So again, when you have disposable infrastructure, it only really works is if you could guarantee that if I destroy and rebuild the environment, that the new environment I just built is absolutely positively the exact same as the one I just destroyed. If there's any real concern of there being some sort of unknown delta or change and things like that, then that concept doesn't really work. And that's really where a configuration management tool like Chef really adds a lot of value, which is you could say, no, I guarantee it's the same because we came from a standard AMI and we use the same exact cookbook with the same exact data bag to build the exact same server. So, we know it's the same server. Having that is extremely powerful, and that's probably one of the largest advantages we have. It took a little while culturally to get that adjusted because everyone's like, well, maybe something is different. We're like, no. And so it took a little while. People who aren't 100% familiar with Chef to realize that the way this works is no. It really gives you a good level of consistency. The other thing is service reuse. So we're using the lightweight service provider framework within Chef. So if we write a service that does a certain thing, like implement SSL certificates on web servers, every application developer and every single platform doesn't have to reinvent that wheel. We actually have that in Bitbucket, and we actually have that as a service that we have in one of our core cookbooks, and I'll get into more detail on that in a few minutes. So we are able to not have to recode logic over and over again. We actually are able to use Chef to provide an infrastructure service platform, if you would. So some other cloud architecture impacts that you need to take into consideration when moving to the cloud from a cloud concept point of view. And then there's some things that you have to take into consideration when you are even migrating into the cloud during the period of migration. So one of the things that Amazon has EBS volumes, but if you're used to having some sort of, like a NetApp or a huge EMC device that you could do NFS mounts to, those don't necessarily exist the same way in the cloud as they do in a data center. So there are, you can still do NFS, you could use, a Gluster server with EBS volumes on the bottom, but the idea of having just, big SAN cabinets that you can just mount to that are all yours, like you have in your data center, it's a little different in the cloud, so you have to adjust to that. The other thing there's no operating system level clusters like HACMP or Red Hat HA. or Microsoft cluster. So if you're using that for like failover for your databases, like a limit cluster or anything like that, that work on a common VIP, so those concepts don't apply in the cloud. So you actually have to, so for your databases, that you have to redesign your high availability structure a little bit. For some databases like MySQL, you could actually leverage RDS, which is a platform as a service offering from Amazon. But if you're using a database that doesn't fit into the Amazon model, like Microsoft SQL Server Enterprise or DB2, you have to leverage a different failover mechanism. For every database we've used, every database vendor has had a cloud-ready package for failover. So it wasn't like we had to do something ad hoc or reinvent the wheel. Every vendor we've worked with has had something out of the box. Obviously, we had to do a fair amount of testing and things like that to make sure it worked for us. But we haven't seen an issue where we were stuck, where we didn't have a technical path forward. As you migrate, there's some concepts in Amazon, and we'll probably get more of this in the Q&A, of availability zones. From my layman's point of view, I look at it as an availability zone as a different data center within the Amazon region. And we'll put servers across the availability zones, the different availability zones, just so we actually have fault tolerance across that. So it gives us a fair amount of redundancy. Load balancing. So in our data center, I don't know if you guys do, but we actually have hardware load balancers. So the idea of having a hardware load balancer in Amazon does not exist. You can use what they call an elastic load balancer or an ELB. But there are some use cases that we found that were the hardware load balancer could do, like layer 7 health checking, that the ELBs don't necessarily do. So as you're migrating to the cloud for your load balancing solution, you have to evaluate ELBs to your current load balancing needs to see if they fit. And if they don't fit, there's other things like HA proxy. So you have to just pay a little bit of attention to load balancing. DNS considerations. One of the things that we had to consider is during the period of migration, we actually had to extend our internal DNS into Amazon and not use Route 53, just because we needed to have the DNS zone for us internally, was Scholastic.net, span both our data center and the Amazon VPC during the period of migration. The idea is that once we finish the migration, is that we'd use pure Amazon's out-of-the-box DNS servicing. Databases I covered, MQ. It's just you have to MQ and Direct Connect are kind of related, which is basically if you're doing MQ during the period of migration between a queue manager that's still in your data center and the cloud, you just have to take latency into account. The way we found to resolve latency, or at least reduce latency to a point where it has a negligible impact on us, is a concept called Direct Connect from Amazon, which allows us to basically look at it like a VPN on steroids. It gives you a dedicated connection between your data center and Amazon. And we've been leveraging it, and we have not seen any, knock on wood, connectivity issues on it since we've brought it up. That's been a while now. This is just a quick slide of outlining what our VPC looks like at a 10,000 foot perspective. We're in the east, so you'll see that we're in US East 1B, 1C, and 1D. So there's another concept in Amazon called security groups. A layman's way of looking at that is they're virtual firewalls that you could put around certain servers. So we actually have one set of security groups that goes around our web servers, our DMZ. We have one set of security groups that go around our application servers. We have another set of security groups that goes around our database servers. So you'll see here too, the way we solved not having a hardware SAN device is we're using Gluster, or if you want to, or Red Hat storage server, if you want to use a community, or if you want to use purchased. And we basically have that sitting on top of a bunch of EBS volumes, and then we use that as our common NFS server for the applications that we have that require NFS. And to date, that's worked out quite well for us. So we haven't really seen any issues in that. We also have, but I don't want to put it in a diagram because it gets a little bit too messy in the diagram. We also have different subnets. So we have one subnet for our web servers, one subnet for our application servers, another subnet for our database servers. And one of the things we're doing is actually we're putting different ACLs into our subnets. Again, this is just to make sure the security stays good and across your entire VPC. Up top is, you'll see there are the ELBs, and we actually do an ELB per app, and that's just our externally, and those are externally facing. So that's our entry point. That's our customer's entry point into the application stack from the internet. The internet gateway is just a NAT device that we have as a certain Omni we get from Amazon that allows our servers to travel out to the internet. And this is, yours might look a little different. This is just a generic overview of what that will look like from a VPC point of view. This is an overview of our automation topology. So this is how we enable our users, and how from an administration point of view, we go from nothingness to a fully working stack. So we actually have, and we have some libraries around Jenkins, but Jenkins is kind of our core engine. Jenkins would call a CloudFormation template. The CloudFormation template would bootstrap an Omni we have. We have several Omnis. We have a 6.4, 5.10. There are certain application packages we have that just the application package takes like 2-3 hours to install. In those cases, we will actually bake an application-specific Omni for that application. A lot of the applications we have install pretty quickly through Yum within a few minutes. So we just basically use basically an empty rel or sent, or basically an empty Linux Omni. So the CloudFormation template will bootstrap it. When it bootstraps it and installs the Chef client, and then assigns that instance a Chef role. The Chef role will have within it a list of cookbooks that's part of that role. Those cookbooks will execute. So an example of that would be, let's say we have an application cookbook that was running on JBoss for sake of argument. The role would call the application cookbook, which would call the JBoss cookbook, which would install JBoss onto a certain server. It'd get the packages from our satellite server. If you're using CentOS, it's called Spacewalk. So it's just basically a channel management tool we have. We have the application teams keeping all their compiled code in another open source system out there called Artifactory. So the cookbook will automatically go out to Artifactory, grab the WAR file, and then deploy the WAR file within the JBoss server. If it needs Apache, we'll install Apache, and if it requires SSL, it'll grab the SSL cert and install the SSL cert within the Apache all at once. So if we're doing this, typically we go from nothingness to a fully working JBoss stack with all the different servers, ELBs, and everything in place in about a half hour. So from start to finish, we actually have a fully working app from zero in about a half hour once we've finished writing the cookbook. I mean, obviously it takes a little longer to write a cookbook. The other thing there on this slide I didn't reference is IPA. IPA is just a centralized security. It's a Linux centralized security tool that we use. Look at like Active Directory for Linux. It allows us to have common usernames and passwords and set permissions uniformly across all of our Linux servers. So getting into the Chef topology here a little bit. So we support several different business units, and they have different needs. So we actually leverage the Chef organizations for each business unit. And then within that, we will actually design multiple environments. And then we'll actually leverage Solar searches within the cookbooks to incorporate all instances in the organization. So let's say, for example, we have one organization which is our e-commerce and our digital space. So basically everything we have that's publicly facing. So we actually have that in one Chef org, and behind the scenes we're using Nagios as our monitoring tool. So when we build a Nagios server, the Nagios server will actually query and grab every single instance that is in that chef org, and it will load that automatically onto our Nagios server. So as we add new nodes, the Nagios server, because we have chef client running at the daemon by default on all of our servers. So as we add new instances, the Nagios server after the next chef run automatically has those new EC2 instances and those new servers added to the monitoring group. We're also putting the Nagios client on the servers automatically via chef as well. So as I kind of mentioned earlier, we're heavily leveraging the lightweight resource provider concept that is within Chef as a cookbook writing principle. And we're leveraging roles and run lists for all of our server builds. So this allowed us to, we look at this from a service point of view, and it allows us to split the responsibility of the functional systems across several teams. And each team maintains their own cookbooks for the functions, and then leveraging those functions is done through the service provider framework. So the services we have this kind of fits part of the old style, but it works out well for us. So we have our systems, or what used to be called the infrastructure team, and we have a certain set of cookbooks that installs the Chef client, installs the core OS, runs the required yum updates, puts the core monitoring tool in there, updates the sudoers file, does updates to resolve.conf, does some core operating system and core monitoring systems. So all those cookbooks are maintained by the systems team. And we have a core role that we bootstrap all of our servers with, which lays all those things out there for us. Then we have the middleware set of cookbooks. So, for example, we have a cookbook for JBoss. We have a cookbook for Drupal. We have a cookbook for Apache. We have one for Drupal. We have one for Varnish. So we have these middleware cookbooks. And so the way these middleware cookbooks are is if you run them with just a default.rb, it will install whatever that middleware is, JBoss, Apache, but it'll be vanilla. In other words, it won't have anything on it. And that's usually only used in sandbox when the developer wants to play. Typically what's happened is we have resource providers within those same cookbooks that application cookbooks would call to do things. So the application level, or sometimes we call them wrapper cookbooks, are the cookbooks that kind of control everything. So the application cookbooks will call a resource provider into the middleware cookbooks. So for example, if I wanted to deploy an Apache application, I would call the Apache cookbook with the instance resource. If I wanted that to have SSL, the next thing I would do is I would call the SSL provider, and I'd be passing values into those providers or the resource providers that they require to outline things like server name, application name, certificate name, certificate location, and we actually have templates devised so all the developers know how to use those. Us doing it this way allows the developers to stand up stacks without having to know the guts of what the stack underneath them is. In other words, and we only expose parameters that we're comfortable with developers changing. So we're not going to allow a developer to change the core ulimits on the OS or things like that. So there's certain standards, certain things we have in place that we don't expose to developers, but the developers just know that it's going to work and it's been standardized. And then we do expose things that we do want them to be able to modify through a resource provider. And that does two things. It allows us to maintain governance. It also reduces the amount of both chef knowledge and cookbook writing knowledge and operating system and middleware knowledge that the developers need to quickly write a cookbook and build up their own stack. So by doing that, allows us to remain standardized, and it also allows the developers to quickly iterate and quickly develop without having to understand a whole lot of knowledge. This is basically a visual of what I just kind of laid out, which is the system level cookbooks, have platform resource providers because we have different versions of Linux and from different distros. The platform providers typically look at the environment files. So this is actually interesting, and it came in kind of handy for us. So recently we had one app that we were planning on moving to Amazon, And, so we built Dev and QA in Amazon, and then the business wanted us to make a change, or wanted to make a change, and the business wasn't comfortable moving the production to Amazon at a certain period of time. But the hardware it was currently on was running out of date. So what we did is we actually leveraged the Chef VMware plugin. And so even though we've used the same Chef cookbook to build those servers in Amazon for Dev and QA, we leveraged the same cookbook and we built those servers on VMware for performance and production. And all we did is in the environment file for the platform, there's different flags our cookbook has, and one says call the Night plugin or the Chef plugin for Amazon, and one says call the plugin for VMware. But from a cookbook coding point of view, we didn't have to make any changes. So we defined an environment. An environment file said use VMware, not Amazon, and we were able to spin that entire environment up in VMware. And then later on, when the code freeze or the freeze we had, passed, we were able to, finish migrating the application over to Amazon. The functional resource providers, I'm jumping up a level here in the diagram, which is the middleware platform cookbooks. This is, again, the Apache, JBoss, Drupals, DB2s, and WebSpheres. These basically, again, like I said, have functional resource providers. Things that don't change per environment or are not dynamic, we'll put in attributes. Things that do change, we will simply we'll define those as parameters you call into the resource provider with. And that calls, as you see here, will come from, I'm jumping up here, the application cookbooks. You'll see the application-specific recipes. We'll make calls into the functional resource providers depending on what the application needs. And then all the different values, all the dynamic values that may change per environment that the application may need, we're keeping in Chef encrypted data bags. So basically, if you look at our platforms, every application stack has its own data bag. And then within the data bag, each ID within the data bag, which is just a JSON document, represents an environment. So, I was meant to take this out. So, forget the first point. We actually do use the data bags not very differently. I'm sorry, I apologize if I pulled this slide out. We do use the data bags like Chef wants us to use data bags. The data bags are application specific. All dynamic application, like I said, is kept in the data bag. So some of the sample code you'll see in the application cookbooks is basically they're grabbing the data bag name and then we're grabbing the node environment. And that node environment will have a data bag ID associated with it, and then all the values you need for that environment will be in that data bag. This also allows us to do something that we like to do, because one of the things we put in the data bag is database usernames and passwords. So what we do is the developers have a data bag encryption key that is pretty open. So everyone can decrypt anyone's data bag in development because it's development, we don't care. The systems teams, operations teams actually have a different key that we encrypt the values of the QA and above environments. So what does that mean? It means even though anyone can see the data bag, the developers can't really see the values of the data bag for the environments that we've encrypted with a different key. So it allows us to not have to rechange our framework between environments, keep the framework and the cookbook code the same, and still maintain security, because without that key, no one else outside the secure teams can actually see the values for the production to passwords and things like that. So you can actually encrypt multiple IDs within the same data bag with different keys, and we're actually doing that successfully. So a flip side of that, of what we're doing here too, is on the development side. And this is a quick slide that outlines what changes that have been made with the development teams as far as how they're also embracing the cloud. So they're actually using, the developer develops their code, and what we're doing right now is we actually have Vagrant in place, so that they'll actually develop code. They'll have a test of a quick cookbook and using a Vagrant file, and actually have Vagrant running on EC2 instances. When they're done running their code, whether it's in their code, by code I don't necessarily mean cookbook code. Their code could be Java code, Drupal code, PHP, whatever application they're writing. But they have their own little sandbox to play in on Vagrant. When they're done, they'll deploy it to they'll kick off a Jenkins job. The Jenkins job will compile their code if required, and then move their code to Artifactory. Once the code's in Artifactory, if they want to see it go into one of our live environments on the SDLC, in other words, Dev, QA, Prod, we will update the data bag, because one of the things we have is the code version is a data bag value that we've put in each application data bag. As we change that value, it will go back to Artifactory, grab the whatever new tag value we put in there, grab it from Artifactory, then Chef will automatically move that code to the server. And if you're patient, you just change the data bag and hit save. Within a half hour, Chef will automatically just deploy it. If you're impatient, as soon as you're done changing the data bag, you simply run Chef client. So some takeaways, from moving to the cloud is plan and prepare. You're really going beyond your infrastructure. In other words, you don't look at infrastructure as, all right, this is my server. I'm gonna live with my server for a while. Servers are transient. They come and go. The real thing that stays persistent are the services that you're offering the business. And then be flexible and then take advantage of cloud technology. One of the things, like, we did an upgrade on one of our old systems. We were on AIX. We had to move from AIX 5.3 to 6 on one of our platforms, one of our larger platforms. That project took us, and just to deploy that upgrade to production before we moved to Chef, we did it manually. Took us about 4 to 5 weeks to do. When we built that same platform via Chef, we built production from nothing to fully running in a day. The other thing that's probably worth noting that we really took advantage of is a few months back there was everyone might remember this, the Heartbleed bug. With Chef in place, what we were able to do is one of the flags we have for our system cookbook, one of the flags we have in the environment files for our systems cookbooks is run yum update, yes or no. And we are able to put the patch for Heartbleed into our satellite server into the channel. And then environment by environment, we flip that yum update from no to yes. Within 30 minutes, that entire environment was patched. The next environment, the next environment, the next environment. So we were able, without a lot of people having to manually do this, patch up our environments via Chef and our automation framework, Chef, satellite, really quickly. The downside of the Heartbleed thing is we weren't fully migrated onto Chef yet because we're still in the middle of our migration schedule. So every single server that was not migrated in our legacy data center, we had to have system admins basically spend like 18 hours straight getting those servers patched. But the servers that were actually in the cloud and that were leveraging Chef were easy. The ones that weren't. And with that, I'm going to pass off and let you guys ask some questions, and I'm going to turn it back over to Justin.
Awesome. Darren, thank you so much. It's really impressive what you guys have accomplished. We've got a bunch of great questions, so I'm going to invite Julian and Chris to sort of come off mute and join us back here. We're going to step through a couple of the questions that we've got throughout the session here. I think the first one is kind of Julian's probably the most qualified answer. Julian, you spent a lot of time out with customers. Obviously, we heard Darren sort of tell the Scholastic story. One of the questions is this a pretty typical route to adopting Chef and automation and DevOps? Is this a typical story? Is this atypical? Sort of what is your perspective on Scholastic's story?
Yeah, this seems to be a pretty typical story of large enterprise moving to the cloud, and a lot of enterprises have similar concerns about we're not in the data center business, right? We're in in this case we're in the publishing business or whatever, right? So that is very typical, and it does take some time for you to kind of understand for enterprises to understand like what the moving parts of the cloud are, and sort of it's not always just an immediate direct kind of lift and shift. And I think that's an important point. purely put forward, right? There's lots of things that are different in the cloud, and they're designed, the cloud is often designed for autonomous systems acting on their own, which is why features like, filers or shared storage systems don't sort of exist there, right? So it requires you to kind of analyze whether or not your application can be moved directly, or whether or not some applications need to be adapted, or whatever. You need to build parts that don't exist when you're in your data center into the cloud instead.
Yeah, awesome. Julie, you just kind of touched on something, and Darren, maybe sort of conversationally here, one of the things that struck me is something Julian just mentioned, and that's this whole idea of you guys took this concerted effort as an organization and said, we don't want to be in the data center business, right? That's not our core business. And the thing I was wondering is, was that a hard sell inside of the IT organization where, presumably people had been, that had been a big part of their livelihood is running those systems. So how did you sort of culturally and organizationally sell this transition?
So, there are two parts to that, right? So, the initial selling it and selling it to our leadership, you might be surprised, but actually was quite easy. Selling it to the ops teams and some of the other the development teams took a little longer. So I know I see a question here: was it hard for the ops team to give up some of that, them doing all the work? Yes, it did. It was a little hard for them to take it over. It was also hard on the dev teams. So one of the things we found is, when we're doing ops, right, the dev teams are like, give us control, give us control. When we wrote the cookbooks, and we have this, this data bank, which is this JSON document that defines their entire stack and the entire environment. We said, here's the JSON document. It belongs to you. If you need another dev environment, just make the modifications as you see fit, and upload the JSON document, and you can rebuild your environment from scratch. And then the dev teams are like, well, that means I need to know all my database ports, all my MQ ports, all my MQ names. We're like, yes, it's your environment. You are an empowered developer. And then that took them a little while. At first, they're like, oh, well, you usually do this for us. We don't want to do it ourselves, bro. But we were like, you asked for it. Here it is. With great power comes great responsibility. So at the leadership level, it wasn't that hard. At the local management level, it took a little bit more convincing.
Interesting. Well, one of the you gave some really great examples around Heartbleed, and I think it was an AIX stack, and gave some examples of sort of the time it took to upgrade, do some things in the old world versus the efficiency of the new world with automation and Chef. One of the things you didn't mention, and maybe you don't have this exact, but where are you guys in this migration? Clearly, you've moved a bunch of workloads up to AWS. You guys are having a very positive experience there. Are you completely out of your legacy data centers? Where are you in that process?
So we're not completely out yet. We're deep in the middle of it. We are expecting to be done with our migrations by the May 2015 timeframe. We've moved over a lot of apps already, and then every new app is going directly into the cloud.
Right. And so as that migration takes place, is that how the Chef tooling and the automation is happening? Is that part of the process? Is you go to AWS and you're writing cookbooks and you're adopting Chef and automation as you make that move?
Yeah, so basically 99% of the time, yes. And the hosting platform, yes. Basically, you don't go to the cloud without leveraging automation in Chef. So purposely, yes, that's the answer.
And maybe a question for Chris on the AWS side. Chris, you work with a lot of customers, obviously, on AWS adoption and a lot of these migrations. Maybe I'll ask a similar question I asked Julian. Is Scholastic, is this a very typical type of migration? And maybe more pointedly, are you seeing a lot of people, when they make this transition, moving to an automation and a sort of DevOps culture and process, and some of the things Darren discussed internally?
Yeah, sure. I think that's a great question. I think that it is definitely a great example of what we're seeing other customers do when they're moving to AWS. The story of needing to look at how you're running things today, take an inventory of both your practices, the technology that you're running, how you're developing code, how your teams work, and then shifting them potentially into, you know, a new, more flexible model. I really see this as kind of a twofold win for the team at Scholastic. They both got to get out of data centers, which is what they were looking to do, but they also got to make their teams much more agile. So when we talk about things like DevOps cultures, which can be kind of a very, you know, loaded term sometimes, and means a lot of things to a lot of people, you know, when I think of it, I think about the idea, much like Darren was saying, right? They were able to enable their developers to fire up infrastructure, to do testing, to do development work without having to impact production, without having to impact the day-to-day workflows of the operations and infrastructure teams. And so from that perspective, that's one of the great things about cloud is the ability that you can kind of democratize the infrastructure inside of an organization, you know, share resources, enable people to be able to fire up resources as they need to, and then have them taken down when they're not needed any longer. And so I think what the folks at Scholastic went through is very typical of what we see many of our customers do, and sets a really great example.
Yeah, I totally agree on your sort of, you know, there's a lot of people throw around the phrase DevOps and enterprise migration, and so I really appreciate, Darren, you joining us and giving us really specific examples of what you guys did and the topologies. One very specific question we got during the webinar was, at Scholastic, are you guys using public or private subnets in your instances? Darren, do you know that off the top of your head?
Yeah, so our DMZ, which has nothing but our ELBs, are on public subnets. Everything else we have within our VPCs are on private subnets. 10.x, for example.
Right. Cool. Okay. See, I'm flipping through. We got kind of a couple more other questions here. One of the questions is, what type of local and CI testing are you using, and how do you think about cookbook versioning and stability? Darren, that's one for you there, Darren.
So by CI, I'm assuming you mean continuing integration. One of the environments we have for all the apps is called continuing integration. I'm assuming that's what you mean by CI.
Yep.
And we're using Jenkins, and we're using our QA tools for that. How do we ensure stability for cookbooks when versions are combined? So we do testing on our own, and we actually have because there's a versioning within metadata.rb. You know, it's like 0.0.1. There's a 3-octave versioning tool. So anything that's in the far right one, if it goes from like .1 to .2, during our life cycle, if we put it there, it means that no other cookbook will be impacted by that. If it's in the middle one, it means that it's a reasonably significant patch, and it needs to be tested by the other cookbooks, but may not break it. If it's the far left one, if it's a significantly new version, then it requires a respin of that server and potentially a modification of all the other client cookbooks. Might have to be refactored to use it. So, for example, we're working on a new version of our system cookbook now as we prep for Realm Cent 7, and there are some significant differences between that versions of Linux. So that version, that cookbook, would require different spinning and also require a downstream impact to our cookbooks. So we laid out the governance for all this very early on. So earlier you heard me say work with your vendors and work with Amazon to get your governance in place first. So we actually did that. We worked with Amazon early and an Amazon partner early to get our governance. And we did the same thing with our chef and our versioning. Actually, to be honest with you, the person who actually laid out our chef governance for us and allowed us to be successful actually was Julian. So I'll give him the credit there for our ability to move reasonably quickly and keep our cookbooks from a organizational point of view very stable.
Great. Darren, we have a couple more very specific questions that I'd like to try to get through, and then we're almost out of time. One of them, how long does your core role cookbook take to run? I don't know if that's something you know off the top of your head, but...
Yeah, so our rule of thumb is the cookbook run during provisioning should be no longer than 30 to 35 minutes. And that's because sometimes you run update. But after that, Chef client runs every half hour, and the Chef run typically takes between 2 to 3 minutes, sometimes 4 minutes. But the Chef run, the update Chef runs are very fast. The chef runs for provisioning, the initial bootstrap one is typically no more than a half hour.
Got it. One of the other questions is, I'd say pretty high level, and I'm sure you don't have